Well, you know, I keep wondering when we gaze at these fleeting visitors from beyond our solar neighborhood, what are we really looking at? And perhaps you've felt it too, that quiet tug of curiosity, like someone tapping your shoulder in the dark of night, asking a question you can't quite ignore. What if an object like 3I Atlas isn't just a wanderer passing through, but a reminder that the universe is far stranger, far more intricate than the stories we've written about it so far? You see, every interstellar traveler arrives without a name, without a history we can trace, and yet it carries the fingerprints of places we may never see. And that's the thing. When scientists point their instruments at such a visitor, they're capturing only a moment, a single shimmering frame in a cosmic film that has been playing for millions of years. It makes you wonder what we're missing between those frames, and what slips through the cracks of our understanding. Could a grain of dust, a whisper of plasma, or a sudden shift in sunlight rewrite what we think a comet is meant to be? In 2025, our tools are sharper, our understanding deeper, and yet each new discovery still humbles us. It reminds us that the universe doesn't owe us consistency, it's not predictable, it's a kind of restless ocean of possibility. It offers mysteries, and it waits to see whether we dare to follow them. So I suppose my question for you is this. If an interstellar object can change its nature faster than we can agree on what it is, then what does that say about our place in this vast, restless cosmos? What does it reveal about the stories we tell to make sense of the dark we keep trying to illuminate? We grow older, clocks tick, and yet the cosmos continues to surprise us, not just with answers, but also with the sense that the answers might shift under our feet, whether it exists at all in the way we imagine. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. All right, so imagine this. Somewhere out there, beyond the icy edges of our solar system, a small and silent traveler begins its journey. It's not large, not bright, not even steady in form. And yet, for a fleeting moment, it drifts across the sky and enters the field of our telescopes. We name it 3I Atlas. Just another number, another entry in a growing catalogue of interstellar visitors. But then, the data comes in and something feels off. Its light curves rise and fall like a heartbeat. Its spectrum, flat and featureless, refuses to confess what it's made of. And that's the thing, this little wanderer seems to hold a secret. You see, science often pretends to be certain. We like our measurements crisp, our explanations neat. But when an object like 3I Atlas passes by, it exposes the fragility of that certainty. Each telescope captures a different face of it. Each night reveals a different mood. One group reports jets of dust, another sees nothing but a pale, static glow. It's like watching a film where every frame is painted by a different artist. The result? Confusion, disagreement, wonder. And we begin to realize that the problem is not the data, it's the moment. We're taking snapshots of a system that lives in time, that changes faster than we can chase it. That's what I sometimes call snapshot science. We freeze a living phenomenon into a still image, then argue about what it means. But nature doesn't pause for us. It shifts, it breathes, it transforms. So maybe 3I Atlas isn't inconsistent. Maybe it's just alive in its own quiet plasma way. And well, that leads us to something deeper, the idea of metastability. Imagine a system balanced on a knife's edge, where a whisper of solar wind or a flicker in the interplanetary magnetic field could tilt it from one state to another. That's 3I Atlas. Not an inert rock, not a simple comet, but a charged dust plasma ensemble dancing between equilibrium and collapse. It's neither frozen nor burning, neither asleep nor awake. It's poised, waiting for the next cosmic breath to stir it. When we think about it, it's not so different from us, is it? Our own lives hover between order and chaos, between calm and ignition. The universe seems to enjoy these fragile states, the moments before something happens. Now, you might ask, why does this matter? Why spend nights debating what kind of comet this is? Well, because it forces us to ask a larger question. What do we even mean by interstellar visitor? Is it a piece of another world, a relic from a distant star? Or could it be something stranger, a fragment of physics we haven't yet met? The very act of naming it, of calling it 3I Atlas, implies we already understand its nature, and maybe we don't. Maybe each of these travelers is a message written in a language we've only begun to hear. Let's think back for a moment to the first of these visitors, 1I Oumuamua. A body without a coma, no tail, no glow. Just a sliver of rock accelerating as if pushed by something unseen. Then came 2I Borisov, a familiar face, a comet in the old sense, gassy and alive. And now 3I Atlas, something in between, something that refuses to stay in any box we've built. It's not just a third case, it's a third way, not a bridge, but perhaps a new category altogether. The more we look, the more we realize classification itself is fragile. We like to believe that naming is knowing, but sometimes naming is just drawing a line in fog. Science thrives on precision, yet the cosmos is under no obligation to be simple. What if, out there beyond the heliopause, there exists a whole menagerie of matter, dusty, magnetized, electrically alive, that defies our current chemistry, a cosmic zoo of unknown species? And that thought humbles me. It suggests that every new visitor isn't just a curiosity, it's a revelation, an invitation to rewrite a few quiet lines in our textbooks. Of course, some people, when they see the odd symmetrical jets and the sudden flickers of activity, they whisper another kind of story, a technological one. They imagine an artificial construct, a probe, a sign. It's tempting, isn't it? The symmetry, the precision, it teases the mind. But science, real science, must hold its breath before it dreams. Extraordinary claims demand extraordinary evidence. A repeating signal, a geometric structure, a spectral line out of place. Until then, we walk the slower, humbler path, the path of natural explanations. Still, I like that tension, the pull between wonder and skepticism. It keeps science human, because we don't want to close the door too soon. We don't want to say impossible, we just want to say not yet. And maybe not yet is where curiosity lives. The more we study 3I Atlas, the more it becomes a mirror. It reflects not only the light of distant stars, but our own hunger to understand. We project onto it our need for order, our fear of uncertainty, our longing to belong to something larger. You know, it's not just out there in the cold, it's in here, in the questions we dare to ask. And so perhaps instead of asking, what is 3I Atlas? We might ask, what kind of universe makes such a thing possible? What kind of laws, what kind of chaos could give birth to a body that glows and fades like thought itself? The answers won't come easily, but that's the beauty of it. Every unknown visitor from the dark reminds us that the map of creation is still unfinished. In 2025, we have instruments that can see the faintest glimmer, past the tiniest fluctuation, but even so, the cosmos keeps surprising us. Each dataset, each pixel of light feels like a whisper from something vast and unseen. We don't have enough data, not yet, to reconstruct the whole dance. We see pieces, fragments, just enough to keep us awake at night. And maybe that's how it should be. Maybe science is meant to be an act of faith, a faith in curiosity, in evidence, in the idea that truth is worth chasing even when it hides. 3i Atlas then becomes not a puzzle to solve, but a doorway to walk through, a momentary reminder that we are small creatures watching immense stories unfold, one frame at a time. And as its trail fades into the black, as it drifts back toward the interstellar night, another thought begins to form. If dust can shimmer with electricity, if sunlight can sculpt plasma into fountains, then perhaps we've been thinking about propulsion all wrong. Perhaps dust itself can move worlds, but that's another story. And it begins, well, right where the dust starts to glow. And so as the faint trail of 3i Atlas dissolves into the dark, we turn to the dust it left behind. Tiny, charged grains suspended between sunlight and silence. You see, in space, dust isn't just debris. It's alive with interaction, with possibility. Each speck, smaller than a human hair, can carry an electric charge, a pulse of energy born from ultraviolet light or the steady breath of the solar wind. And when these grains begin to move, when they start to whisper to the surrounding plasma, they reveal something almost poetic, that even the smallest fragments of matter can hold the power to move worlds. We've long imagined comets as icy bodies, driven by sublimation, ice turning into gas, gas pushing against sunlight, the slow and steady exhaust of ancient frost. But, well, maybe that's not the only story. Maybe dust itself can be a kind of engine. Maybe the cosmos has been hiding another form of propulsion right in front of us, quiet and shimmering in the light. When the Rosetta spacecraft circled Comet 67P, scientists noticed something peculiar. Jets of dust were leaping from the surface at times when sublimation shouldn't have been strong enough to explain them. It was as if the comet had found another way to breathe. That observation planted a seed, a small stubborn thought. Perhaps electric forces, not thermal ones, were in control. Perhaps what we were seeing were not plumes of vapor, but fountains of charge. Imagine it a surface bathed in ultraviolet radiation, each photon knocking electrons loose, leaving behind a landscape of positively charged grains. And, well, as the solar wind sweeps by, these charged particles begin to dance. The surface repels them, pushes them upward, ever so gently. The field builds, collapses, builds again. And the dust, obedient but restless, lifts and falls like breathing. This is what scientists call electrostatic fountains. Small, subtle, but persistent. A process that could, over time, shape tails, jets, or even trajectories. And if a body like 3i Atlas carries within it a composition conducive to this, if its surface holds conductive minerals, micrograins that respond strongly to electromagnetic fields, then the picture changes entirely. It's no longer just ice evaporating in sunlight, it's electricity sculpting dust into light. It's not just chemistry. It's physics, alive and humming. And I suppose that's the beautiful part, isn't it? That we thought comets were frozen memories, and now they seem to be electrical instruments resonating with the music of the Sunday. When you think about it, the solar system itself is an enormous plasma experiment. Every planet, every grain of dust, every tail of a comet, all of them immersed in the same invisible sea of charged particles. And that sea doesn't flow uniformly. It ebbs and pulses with storms, with flares, with magnetic waves that span millions of kilometers. So when an object like 3I Atlas enters that environment, it doesn't just pass through, it interacts, it responds, it sings back. And here's the curious thing. If 3I Atlas has symmetrical dust jets, if it flickers in near perfect intervals, then perhaps what we're seeing isn't random at all. Perhaps the symmetry is born from regions on its surface that charge and discharge together, synchronized by the rotation of the body and the rhythm of the solar wind. 3 zones, 3 fountains, 3 echoes of balance. It's a thought both simple and profound. That symmetry doesn't always imply design. Sometimes it implies physics at play on the edge of chaos. It's not alien technology. It's natural order arising from the same equations that govern lightning, auroras, and the faint crackle of static when you touch a doorknob. Still, I can't help but wonder, to witness such order in motion, such grace in something as simple as dust, it feels almost intentional, not in the sense of design, but in the sense of elegance. The universe doesn't build machines, but it builds beauty. And, well, that beauty makes us dream. If this electrostatic propulsion truly exists, it changes more than our models of comets. It changes our understanding of motion itself. Because the forces are slow, persistent, continuous, they don't roar, they hum, a steady whisper of acceleration, the kind that could, over years, reshape orbits or subtly push a body off course. And that might be why 3I Atlas, much like Oumuamua before it, displayed a tiny but measurable non-gravitational acceleration, an acceleration without jets of gas, without visible thrust. We once thought only rockets could move with intention. But here, the dust itself becomes the propellant, the exhaust, the engine, and the evidence, all at once. The implications, well, they reach beyond comets. Imagine spacecraft powered not by fuel, but by light and dust sails woven of plasma, charged by the Sunday. It's not just imagination, it's the logical extension of what we see in these wandering bodies. Nature, it seems, already runs the experiment, and yet, the model has its limits. We've tested these theories in laboratories, seen dust levitate under ultraviolet light, but nothing we built can fully mimic the raw vastness of interstellar space. No chamber can hold the silence, no instrument can perfectly imitate the dance of the solar wind. So, every time we compare our models to these distant visitors, we're reminded of the gap, the one between simulation and reality. Still, that gap is where discovery lives. That's where questions grow. Because if we can prove that 3I Atlas is governed by electromagnetic fountains, then it becomes a bridge between plasma physics and planetary science, between comet tails and propulsion systems. It would mean that the cosmos uses the same language everywhere, from auroras on Earth to jets of dust around a distant traveler. You know, sometimes I imagine the moment when the data first appeared on the screen, a faint line, a spectral curve, a shape that didn't quite fit. And in that confusion, in that small mismatch, science moved forward. That's the rhythm of it. Anomaly, doubt, discovery. The great irony, perhaps, is that every answer breeds a new mystery. We solve the question of the jets, and suddenly we must ask about the composition. We model the symmetry, and suddenly we wonder about the origin. Where did such a body form? Near a star? In the aftermath of a supernova? In a region where magnetic fields twist space into invisible knots? It's not just about where it came from, it's about what kind of environment could make dust behave this way. Because dust is history. Each grain holds the fingerprint of its birth, how hot it was, how dense the gas, how strong the field. If we could read that fingerprint, we could trace not only the story of a comet, but of an entire system we've never seen. And I suppose that's what makes this so, well, intoxicating. Every interstellar visitor is a messenger from a world we'll never reach, a sample delivered by the universe itself, free of charge. And yet, as it passes, we can only watch, only measure, only guess. 3i Atlas may be a comet, or a fragment, or something entirely new, but it's also a teacher. It shows us that the boundary between physics and poetry is thinner than we think. The laws that govern charged dust are the same that paint nebulae, that sculpt the Milky Way into spirals, that drive the faint electric breath of our own planet. So when I speak of dust as a propellant, I'm not just talking about engines or motion, I'm talking about continuity, about how the smallest particle participates in the grand machinery of the cosmos. It's not just dust moving through space, it's space moving through dust. And if you listen closely, not with ears, but with curiosity, you can almost hear it, the faint static hum that links us to everything out there. Perhaps in time, we'll build instruments sensitive enough to catch that whisper. Perhaps we'll send probes that ride on that same principle, driven not by combustion, but by charge, by light, by dust. And when that happens, when human hands finally harness what comets have been doing for eons, we'll remember 3i Atlas not as an oddity, but as a guide. Still, the question lingers, how stable are these systems, really? Can a body maintain this delicate balance for years? Or is it constantly teetering, constantly near collapse? And if that's true, if its state can flip with the slightest change in the solar wind, then perhaps what we call activity is not activity at all, but fluctuation, resonance, rhythm. That idea, it brings us full circle, because what began as a question of dust and charge becomes a question of time itself, how quickly, how unpredictably the universe can change its face. And so, as we drift deeper into this mystery, another thought begins to rise, a thought about instability, about equilibrium, about what it means for matter to persist on the edge of transformation. Because maybe, just maybe, the secret of 3i Atlas isn't how it moves, but how it stays together at all. And so we end up here at the edge of certainty. 3i Atlas, this fragile equilibrium of dust and light, has already taught us something profound about how easily matter can change its state. But the real question, the one that hums underneath all this data, is about identity. What is an interstellar visitor, really? Is it a comet, a rock, a plasma cloud, or something that forces us to redraw the categories we've clung to for so long? Because, well, science loves its boxes. We like to know where things belong. But sometimes the universe sends us something that doesn't fit anywhere at all. It started, of course, with One-Eye Oumuamua, that strange, elongated shard gliding through the solar system, spinning in silence, accelerating, without an engine, without exhaust. We thought we understood comets, we thought we understood asteroids, and then came Oumuamua, dry as stone, shining like metal, but behaving like neither. It was, and still is, the first true interstellar mystery of the 21st century. Then, not long after, came 2I Borisov, a relief almost. A comet in the old-fashioned sense, gas, dust, the familiar blue glow of ionized molecules, streaming in sunlight. Borisov was what we expected from another star, proof that the cosmos repeats itself, that other planetary systems forge the same icy relics we see at home. And for a moment, that comforted us. The universe, it seemed, was consistent. And then 3I Atlas arrived, not with comfort, but with confusion. It looked like Borisov at times active, dynamic, radiant, yet its spectrum was flat and silent like Oumuamua's. It behaved like a comet, but it spoke like a rock. And, well, the deeper we looked, the more it shifted between identities. That's when things started to unravel. You see, when a field of science encounters something that doesn't fit, two instincts collide. One is to stretch the old models until they almost explain it. The other is to start again, to admit that maybe our categories are too small. 3I Atlas forces us into that uncomfortable space between the known and the new. It's not just a third visitor, it's a third category. Or maybe it's the first glimpse of a zoo of materials, forms, and physical states that we've never encountered before. We tend to think we've seen it all, rocks, ices, metals, gases, but the truth is, the universe might be running experiments we can't even imagine. In regions near supernova remnants, or inside dense magnetic filaments, matter can behave in exotic ways. Grains can fuse under fields, plasma can solidify, dust can align into lattices that mimic symmetry without structure. What if 3I Atlas is such a relic born in a region where magnetism and radiation sculpt matter into unfamiliar forms? Not artificial, not supernatural, just alien in the truest sense, formed elsewhere under different rules. And that's a humbling idea, because if that's true, then everything we've built, every classification, every label, is provincial. It belongs to our little corner of one galaxy under one kind of star. The cosmos, well, it may contain countless chemistries, countless architectures of matter, and when one of those passes close enough for us to see, we should expect surprise. Still, I understand why the artificial hypothesis comes up. The symmetry, the on-off behavior, the regular flickers, they tug at something in us. We see order, and we instinctively think design. We see geometry, and we whisper the word intent. And yet, that's the trick of pattern recognition, our oldest human reflex. We find faces in clouds, constellations in random dots of light. It's not that we're wrong to wonder, it's that wonder needs discipline. Science asks us to doubt our first stories, even when they sparkle. So, well, to be scientific is to walk that thin line between imagination and evidence. Good science doesn't banish strange ideas, it just places them in order. It says we start with the natural, we exhaust the possible, and only then, if everything fails, we turn to the extraordinary. It's not about dismissing mystery, it's about preserving integrity. Because if we leap too soon, if we call every symmetry alien, we lose the most beautiful thing science gives us: patience. And patience, you see, is what this mystery demands. We don't have enough data yet, not enough continuous observation to map the flickers, to see the full rotation, to track how the activity rises and falls with the solar wind. That's why each group sees a different version of the same object. One catches it awake, another catches it asleep. Together they make a portrait that's both true and incomplete. Perhaps that's the deeper lesson. It's not that our instruments are wrong, it's that reality changes faster than our snapshots can capture. The cosmos doesn't wait for exposure time. So maybe, instead of treating conflicting data as errors, we should treat them as frames, pieces of a moving story. And if we accept that, then 3i Atlas becomes not a contradiction, but a phenomenon in flux, a system moving through metastable states, toggling between order and chaos. It's not lying to us. It's showing us that stability itself is temporary. That equilibrium in the cosmos is always a pause, never a destination. There's something almost human about that. We too live in states of flux, between certainty and doubt, between knowing and becoming. And perhaps that's why we find these interstellar visitors so haunting. They mirror us. They remind us that even solid things can change, that even light can mislead. If we could trace 3i Atlas back to its origin, what would we find? Maybe a system scarred by magnetic storms, where dust learned to move under charge instead of heat. Maybe a dying star's debris, frozen mid-transformation. Or perhaps, and this thought stays with me, it's a fragment of something larger, a shard of a structure once whole, now drifting, still echoing, with fields that no longer exist. Whether it's natural or crafted, whether it's accident or artifact, well, that might not even matter. What matters is that it reveals what physics can do when pushed to its limits. The universe, after all, doesn't care for our categories. It creates because it must. It experiments endlessly, spilling new forms into the void, and we get to watch. That's our role in this vast laboratory, to observe, to question, to be amazed. So maybe it's time we stop asking, what is it? And start asking, what does it teach us? Because in the end, each interstellar object is not an answer, but a test of how we think, how we adapt, how we hold mystery without breaking it apart. And perhaps that's what this crisis of classification really is, not the failure of knowledge, but a milestone of understanding. When nature gives us something that doesn't fit, it's not chaos, it's evolution, it's the universe, stretching our minds a little further. So, well, the next time we point our telescopes and see another faint visitor streaking through the sky, we'll remember that it's not just a body in motion, but an idea in transformation, not just a rock or a comet, but a challenge, an invitation to see matter and maybe ourselves in new ways. And as we drift from this thought, from the crisis of identity to the quiet persistence of dust and charge, another question begins to take shape. If matter can switch its state so easily, if energy can sculpt motion from light alone, then perhaps propulsion itself, the very act of movement, is not what we think it is. Perhaps the universe has been showing us a gentler kind of force all along, one woven through electric fields and drifting grains of dust. And that, I suppose, leads us into the next mystery, how the smallest particles, guided by invisible fields, might become the engines of cosmic and so. And so from that thought, from the whisper of dust turning into motion, we step into another question, one that hums quietly beneath all of this. What is it, really, that drives these bodies through the void? What makes them move in ways that seem deliberate, almost graceful, when no visible force pushes them? You see, when we think of propulsion, we think of explosions, of engines, of fuel burning in defiance of gravity. But the cosmos, well, the cosmos moves differently. It moves softly. It moves through fields. Perhaps that's what makes this so beautiful, the realization that in the emptiness between stars, force doesn't roar, it whispers. The push isn't mechanical, it's electromagnetic. Not jets of gas, but tides of charge. Not thunder, but static. And uh, that changes everything. Imagine, for a moment, a tiny grain of dust floating in sunlight. It looks still, but it isn't. The photons that strike it carry momentum, tiny, but relentless, pushing, nudging, sculpting. Light has weight, though we rarely think of it that way. It can move matter, spin it, charge it. And in space, where friction doesn't exist, those faint nudges accumulate. So, over hours, over days, over centuries, light becomes wind, and wind becomes power. This, I suppose, is where physics starts to sound like poetry, because the same sunlight that warms your skin on Earth can, over vast distances, propel a fragment of dust across the solar system. And not just dust, entire worlds of dust, comets, tails, streams, all subtly pushed and shaped by radiation. That's not a metaphor, it's a fact. And yet, there's more. There's something subtler still, the play between charge and field. The plasma that fills interplanetary space isn't neutral, it's alive with electrons and ions, shifting like a restless ocean. When those streams meet a charged surface like that of a comet, or, say, 3I Atlas something, extraordinary happens. Electrons are stripped, currents flow, and the body begins to respond. Its surface regions build up, charge unevenly. One area glows, another dims. One side repels dust, another clings to it. The whole thing becomes an electrical sculpture, balancing invisible forces like a conductor with no audience but the stars. And, well, that's the key. This dance between dust and plasma, between sunlight and field, might be what drives 3I Atlas. It's not a comet in the old sense. It's a self-organizing system, not static, not chaotic, but something in between. Metastable, that word again, balanced on a ridge between silence and eruption. If you could stand near it, if you could watch from just a few hundred kilometers away, you wouldn't see an explosion or a flare. You'd see dust grains quietly lifting from the surface, floating upward as if gravity had forgotten them. You'd see faint halos forming and dissolving, 3 bright plumes, perhaps evenly spaced, each one a child of the same electric tension. And then, as the solar wind shifts, the plumes would fade, fall back, vanish. The cycle would start again. It's not chaos, it's rhythm, it's breathing. We often think of the universe as dead and mechanical, but phenomena like this remind us how alive it truly is. The sun doesn't just shine, it sings through its wind, through its fields, through the tiny charges it scatters across the planets and beyond. And when those invisible waves meet an interstellar traveler, they don't merely strike it, they play it, as if each object is an instrument in a cosmic orchestra. So when we say dust is propulsion, it's not a metaphor for beauty, it's literal. The grains, once charged, are pushed by electric fields that shift direction with every breath of solar weather. Each grain that leaves the surface gives the body a recoil, a microscopic thrust. Not much, but constant. Over time, it adds up. It moves the comet, changes its spin, alters its orbit. The motion, we see the strange non-gravitational acceleration, isn't mystery. It's the accumulation of whispers. But here's where things get even more interesting. If this model holds, then we have to rethink what activity means. Because when we observe 3I Atlas glowing and fading, we might not be seeing sublimation at all. We might be seeing the charge cycle, the slow build-up and sudden discharge of static energy across its surface. Each brightening, each pulse is the visual echo of that exchange. Not ice melting, but charge rearranging. It's a humbling idea that electricity so mundane on Earth could be the sculptor of comets, the painter of tales, the hidden artist behind the blue-green light that trails across the void. And I suppose, well, that opens a door. If comets and dust can move this way naturally, what else might? Could small asteroids, the ones with odd accelerations, also be playing the same game? Could the universe be filled with tiny self-electrifying engines moving not by chemistry, but by light and field? It's not just speculation. In the lab, under ultraviolet lamps, we've seen grains levitate, twist, and launch from surfaces that mimic regolith. We've seen that the process doesn't require heat, only imbalance one region more charged than another. The physics is real. The question is scale. Can such a process, born from something so small, move something as large as a comet nucleus? And if it can, then the consequences ripple outward. Because propulsion, in that case, isn't a privilege of technology, it's a property of nature. The cosmos itself has engines, quiet ones, invisible ones, made of dust and sunlight. We keep thinking propulsion is about control, that to move, we must burn, we must push. But here's a different story. To move, one must only listen, to align with the fields already flowing, to let charge and light do the work. It's not resistance that drives motion, it's resonance. There's something philosophical in that, don't you think? That what moves most gracefully in the universe isn't the thing that fights the wind, but the thing that flows with it. Not power against, but harmony within. And if that's true, then 3i Atlas isn't just a comet, it's a teacher. It shows us that nature doesn't separate force from beauty or motion from stillness. The same principles that guide a lightning bolt across a stormy sky might guide a dust plume through interstellar night. It's all the same physics, just stretched across scale and time. Now, imagine taking this further. If light and charge can move a comet, can they move a spacecraft? Could we, one day, ride those same invisible currents, not as observers, but as participants? The idea isn't new. Light sails, plasma thrusters, ion drives, all human echoes of the sun's quiet method. But maybe, just maybe, what 3i Atlas shows us is the deeper version of that idea. Not technology imitating nature, but technology joining it. To think that a human-made craft might one day travel the stars using the same subtle push that guides dust across the void, it's strangely poetic. Because it means that when we go out there, we won't just bring machines, we'll bring understanding and alignment with the forces that already shape the universe. Still, before we get there, we must first prove it. Data, spectra, light curves, they must all align. And that's where patience becomes everything again. Because these are not quick experiments. The changes happen slowly, over hours, over days. Instruments must stare, unblinking, through noise and shadow to catch the faintest fluctuation in brightness. That's how truth arrives in astrophysics, not as revelation, but as persistence. And even then, even with the clearest data, questions remain. How strong must the local electric field be? How conductive the surface? How fine the dust? How stable the charge? Each answer, you see, unfolds another layer of wonder. Each certainty carries a shadow of doubt. And maybe that's the point. Science isn't about erasing mystery. It's about deepening it, about finding more beautiful ways to be uncertain. 3i Atlas is doing that to us, forcing us to hold competing truths, to accept that the universe may be both familiar and utterly alien at once. When I think of that, I can't help but picture the dust again, billions of tiny particles, each alive with light, each drifting through magnetic whispers. It's not just dust moving through space, it's space itself rearranging around dust. And that's where our story turns next. Because if the interplay of dust and charge can move comets, then perhaps, deeper still, it can explain something even larger, the way light itself sculpts the universe, how photons and plasma conspire to shape the very architecture of the cosmos. And that, well, that's where we go next, into the light that not only reveals but creates. And so we arrive at a kind of crossroads, the moment where theory and wonder begin to overlap. You see, light doesn't just reveal the universe, it sculpts it. It doesn't just illuminate matter, it moves it, transforms it, gives it shape. And, well, nowhere is that clearer than in the strange case of our interstellar visitors, the wanderers that glide through our system and vanish again, leaving behind nothing but questions. Perhaps, to understand 3i Atlas, we must look back to the first messengers that came before it, because, well, this story didn't begin with Atlas at all. It began in 2017 with something small, silent, and oddly shaped. One eye, Oumuamua. Oumuamua was the first confirmed interstellar object ever observed, a sliver of rock, or ice, or maybe something in between, crossing our solar system on a hyperbolic path that would never return. It entered our lives like a spark and vanished just as quickly. And yet, what it left behind was a trail of confusion. No tail, no coma, no visible emission, just a fading point of light that somehow accelerated as it left the Sunday. Not much, but enough. Enough to break the rules, enough to whisper that there was something we didn't understand. And the theories came: hydrogen ice, nitrogen shards, fluffy aggregates, metallic foils. Some even suggested, something artificial. But each idea, in its own way, felt incomplete. It's as if the object was caught between categories, not quite comet, not quite asteroid, a kind of cosmic orphan, a reminder that the universe does not owe us neat definitions. Then came Borisov, 2i Borisov, and with it, relief. At last, a visitor that behaved as we expected, a comet through and through. It bloomed with gas. It shone with cyan light. It carried the chemical fingerprints of ordinary life-bearing ice. You could almost hear astronomers exhale. Borisov was familiar. It told us that maybe other systems are not so different. The physics of ice and dust repeat themselves across the stars. But that comfort didn't last long. Because when 3i Atlas arrived, everything became strange again. Here was a body that looked, from one angle, like Borisov, active, bright, with visible jets. And yet, when we studied its light, its spectrum was flat, featureless, like Oumuamua. It was both things and neither, a paradox in motion. So what do we do with that? When nature refuses to pick a side, when evidence points in opposite directions, do we call it anomaly or do we call it invitation? Maybe this crisis of classification isn't a failure of science, but a necessary stage in its growth, because every time we find something that doesn't fit, we are reminded that our categories are human, the universes aren't. And perhaps that's what 3i Atlas is trying to tell us, that comet, asteroid, rock, dust, these are words we invented to manage simplicity, not to describe reality. The cosmos, in truth, doesn't sort itself into drawers. It creates gradients, transitions, states in between. Think about it. A comet becomes an asteroid when its ice is gone. An asteroid becomes dust when it breaks apart. A dust grain becomes plasma when it charges. It's not transformation, it's continuity. Everything flows into everything else. And maybe interstellar visitors like Atlas simply reveal that the universe prefers transitions over boundaries. Still, the symmetry of Atlas, those strange, balanced plumes, they tug at something deep in the scientific imagination. 3 jets, evenly spaced, switching on and off like a heartbeat. It's not random, it's not chaotic, it's patterned. And we, humans, well, we love patterns. We can't help but wonder if intention hides behind them. But here's the thing, symmetry is nature's language too. From snowflakes to galaxies, from atoms to spiral arms, order emerges not from design, but from law. It's not artifice, it's consequence. The same magnetic fields that shape auroras can sculpt dust fountains into rhythm. So, perhaps what we're seeing is not the work of intelligence, but the signature of physics operating in a regime we haven't explored yet, the electromagnetic domain of interstellar dust. And that's humbling, because it means the extraordinary is still natural. It means that mystery doesn't need miracle to exist. It just needs time and data and patience. I suppose that's what good science is, the discipline of waiting for nature to speak rather than rushing to finish her sentence. And, well, in 2025, that lesson feels especially relevant. Our telescopes are sharper, our algorithms cleverer, but still the universe stays ahead. Still, it writes stories in spectra we don't yet know how to read. What fascinates me most about Atlas, though, isn't the uncertainty itself, it's what the uncertainty reveals. You see, we've spent centuries perfecting the art of categorizing, of naming. But perhaps the next revolution in astronomy isn't about discovering new objects. It's about learning to live with the ones that defy definition. It's not that we don't understand Atlas. It's that we're learning through it how understanding works. That data isn't static. That truth flickers, like the object itself, visible, then gone, then visible again. And, well, this snapshot science, as some have called it, exposes a weakness in how we observe. We take a moment, a fraction of a rotation, and we call it a whole. But what if the truth isn't in the still frame, but in the movement? What if 3i Atlas changes from one physical state to another over hours, over days, faster than our instruments can keep up? Then every observation is both right and incomplete. That in itself is a revelation, because it means that science isn't failing, it's glimpsing complexity. The more we refine our lenses, the more we see that the cosmos isn't stable, it's alive. And when I say alive, I don't mean biological. I mean dynamic, self-adjusting, creative in its own way. A comet is not just an object, it's a process, the set of interactions between heat, light, charge, and time. It breathes, not in air, but in radiation. It responds to its environment. It evolves as it moves. That realization that movement and identity are inseparable feels strangely philosophical. It's not just about comets, it's about us. We grow older, clocks tick, and we change even when we think we're still. The same applies to matter, the same applies to stars. So maybe 3i Atlas isn't confusing at all. Maybe it's just honest, showing us what we all are, temporary arrangements of energy, shifting between forms. But where does that leave classification? Are we supposed to abandon it? Not quite. We still need structure, but we must build it with humility, aware that every label is provisional, every definition has an expiration date. In that sense, science becomes not a fortress of knowledge, but a garden of possibilities. Each anomaly is a seed. And every seed, when nurtured, grows into something that changes how we see the whole. Oumuamua showed us that not all interstellar visitors behave the same. Borisov reassured us that some do. Atlas taught us that even those two extremes are just points on a larger spectrum. It's not a triangle of types, it's a continuum, a web of phenomena we've barely started to map. And so, well, maybe it's time we stop asking what category does this belong to and start asking what conditions create it. That's a different kind of question. It's a question of origin, not definition, of environment, not identity. Because if Atlas was born in a magnetic storm near a dying star, or in the electric tides of a protostellar disk, then its behavior isn't strange, it's expected. We just haven't been looking in the right neighborhood of physics. The great irony, perhaps, is that every mystery we uncover doesn't make the universe more alien, it makes it more connected. The dust in a comet's tail, the ions in a solar flare, the glow of a distant nebula, they're all part of one continuous conversation between light and matter. And that's what gives this story its quiet beauty. The crisis of classification isn't a collapse of understanding, it's an opening, a chance to see that nature's diversity isn't disorder, but design of another kind, not intelligent design, but the intelligence of laws playing themselves out across infinite scales. So, as 3I Atlas fades from our instruments and drifts back into the interstellar dark, it leaves behind more than data. It leaves behind a question, maybe the most important one of all. Not what is it made of, but what else is possible. And that question is the doorway to the next mystery. Because if matter itself can behave in ways we never imagined, then perhaps we've been missing something even larger, not in the dust, not in the light, but in the fields that bind them. And that, well, that's where our gaze must turn next. And so as our gaze turns toward those invisible fields, the quiet, vast web that holds everything together, something remarkable begins to take shape. We start to realize that dust, the same dust we once dismissed as cosmic debris, might be more than residue. It might be the very breath of motion in the universe. And the more we study it, the more it feels alive, not alive, in the biological sense, but alive in the way wind is alive, or light, or time. Always moving, always exchanging, always reshaping what it touches. You see, in the vacuum of space, that supposed emptiness, dust is everywhere, each grain smaller than a thought, yet countless beyond measure. And though small, they carry charge, they carry memory, they carry the story of the stars that made them. Every collision, every photon, every magnetic ripple leaves a mark. That's what fascinates me. That these tiny drifting fragments are not just the aftermath of cosmic violence, but also the engines of it. In 2025, we've come to think of propulsion as something complex, as thrusters, as plasma jets, as chemistry wrapped in mathematics. But, well, maybe the universe does it differently. Maybe it uses dust, maybe it always has. When the Rosetta spacecraft arrived at Comet 67P, what it found was not what we expected. Jets of dust erupted even when there was no heat, no sunlight strong enough to sublimate ice. The explanation was elusive, too little energy for such a show. And that's when scientists began to wonder whether the cause wasn't thermal at all, but electrical. Imagine this: ultraviolet light from the sun strikes the surface, knocking electrons loose. The grains become charged, repelling one another. The local field grows until suddenly some are launched upward, carried off by the faint wind of the solar breeze. Not just pushed, but guided. It's delicate, continuous, almost like breathing. No explosions, no roar, just a steady hum of electric motion. And uh, that's the thing about electricity in space. It's not noise, it's rhythm. It shapes and sculpts and sings. When a surface becomes unevenly charged, it creates gradients. And those gradients can do work, they can lift dust, move plasma, even alter an object's spin. It's not mechanical, it's relational. The body interacts with the field around it, and both evolve together. So when we say dust as propellant, we're not being metaphorical, we mean it quite literally. Each grain that escapes carries momentum. Each ejection gives the body a push. Not much, but persistent. And in the void, persistence is everything. The universe runs on patience. That's perhaps why 3i Atlas and objects like it puzzle us so deeply. They move, but not because of ice. They glow, but not because of chemistry. Their activity flickers with solar rhythm, as though they were tethered to the magnetic breath of the sun itself. And I suppose that makes sense. The solar wind is not a breeze in the ordinary way. It's a stream of charged particles, electrons and protons, and it carries the sun's magnetic field outward, folding and twisting it across billions of kilometers. Every comet, every grain of dust, every spacecraft that drifts through it becomes part of that pattern. It's not motion through emptiness, it's motion within a living sea. That's what this electrostatic fountain model suggests. The comet's surface, covered in fine dust, becomes a playground for charge. In some regions where composition, temperature, or conductivity differ, charge builds faster. Those spots become fountains. And, as the electric tension grows, dust lifts away, tracing narrow jets into space. When the fields neutralize, the fountains stop. Then, slowly, the charge builds again. On-off, on-off, symmetry in silence. And if the object spins, the plumes may appear evenly spaced, each one a twin of the others, each one flickering in rhythm with the solar field. A natural pattern, born not of design, but of physics. It's elegant, isn't it? Not just because it explains the observations, but because it reveals the subtlety of the cosmos. Nature doesn't always need violence to move things. Sometimes all it needs is imbalance. That's how stars form, too. Imbalance in gravity. That's how galaxies spiral, imbalance in momentum. That's how life arises, imbalance in chemistry. The universe thrives on things slightly out of equilibrium, because when everything is perfectly balanced, nothing changes. And perhaps that's what 3i Atlas really is, a messenger of imbalance. A reminder that even dust can be an engine if the conditions are right. Now, what fascinates me is how this idea connects to our own ambitions. We've dreamed for decades about light sails, ships driven by the pressure of photons. But what if dust itself can be used as propellant? What if we could build small crafts, each seeded with charged grains, designed to harness the same forces that drive comets? It wouldn't be propulsion by force, but by participation joining the natural currents of plasma and sunlight. You see, that's the profound shift. It's not just technology mimicking nature, it's technology aligning with it. We wouldn't fight the solar wind, we'd ride it. And maybe that's the next frontier. Not engines of fire, but engines of field. Not fuel that burns, but matter that listens. Still, there are questions, difficult, technical ones. How strong must the field be? How conductive the dust? How long before neutralization halts the effect? And more philosophically, how do we even measure something that is both cause and consequence, both driver and passenger? Because that's what this phenomenon seems to be self-interacting. The dust creates the field moves the dust. It's not a system with boundaries, it's a dialogue. And, well, the more I think about that, the more it feels like a metaphor for all scientific progress. We push at nature, and it pushes back, shaping our understanding in the process. The experimenter and the experiment are not separate. They co-create. In a way, studying these comets is like listening to the universe talk to itself. Every spectrum, every flicker of light is a sentence in that conversation, a reminder that physics isn't distant, it's intimate, it's not out there, it's in here. Perhaps that's what makes the study of dust so strangely moving. It's both trivial and profound. Each particle by itself is meaningless. Together, they create structure, tails, rings, clouds, galaxies. The universe builds beauty from insignificance. So, when we speak of dust as propellant, we're really speaking of the quiet intelligence of the cosmos, the way it reuses everything, the way nothing is wasted. Even destruction, when seen from the right scale, becomes creation. A comet shedding dust becomes a tail. A star losing plasma becomes light. A dying system becomes a seed for the next. It's not decay, it's transformation. And in that light, 3i Atlas is no longer an anomaly. It's a participant, another expression of the universal principle that everything moves because everything is connected. The beauty of this model and this well is what I find almost poetic, is that it bridges the microscopic and the cosmic. The same equations that describe dust lifting from a comet's surface also describe plasma arcs in nebulae and auroras dancing across polar skies. It's all one language. And if that's true, then each interstellar visitor is a verse in the same song. Some quiet, some bright, but all in harmony. Now, when we look back at Atlas and at Oumuamua before it, we can start to see a pattern emerging, not of repetition, but of relationship. Each visitor expands the range of what's possible. Each one shows that the physics of matter and light can invent behaviors we've never imagined. It's as though the cosmos keeps testing us, offering us puzzles to see how far our imagination will stretch. And we stretch, because that's what humans do. So perhaps the next step isn't to explain these phenomena away, but to follow them, to design missions that chase them, to send instruments that can feel the charge of the solar wind, that can watch dust lift and fall in real time. We're already dreaming of that small, agile probes that could intercept the next interstellar visitor before it vanishes again into the dark. It won't be easy. These objects come unannounced, unpredictable, swift. But then again, all of science has always been about catching fleeting things, light, time, truth. And I think that's why this pursuit matters, because in chasing them, we're not just studying dust, we're studying ourselves, our patience, our curiosity, our willingness to look again and again until the universe finally answers. The future of this field, well, it depends on how we listen, whether we continue to impose our theories on the sky or allow the sky to correct us. And perhaps that's the most beautiful thing of all, that these silent, glowing fragments drifting between stars could teach us humility, that they could remind us that knowledge is not conquest, but collaboration. As we move forward, as new telescopes rise and new data streams in, I can't help but feel that each discovery will bring not certainty, but wonder, and that's enough. Because, well, every interstellar traveler, every Atlas, every Borisov, every nameless speck of dust is a gift, a glimpse of how the cosmos experiments with itself. And so, as we follow that dust farther into the dark, perhaps we'll find that propulsion, charge, and light are only part of a much larger story. One that doesn't end with movement, but with meaning, with the quiet realization that the forces that shape the stars also shape us. And that leads us onward to the final thought, to the moment where science and awe meet, where we must ask not how the universe works, but why it feels the way it does. And as we follow that dust farther into the dark, we begin to sense that the real story of Three-Eye Atlas isn't just about a comet or even about a mechanism. It's about us, about the way we reach for meaning when the universe gives us something we can't quite explain. You see, for every discovery that reshapes our understanding, there's a quiet reckoning that follows, a moment when science pauses, looks at itself, and wonders, how much do we really know? How much of what we call knowledge is just approximation, an elegant guess, draped in confidence? Three-Eye Atlas, well, it's become that kind of mirror, a small, fleeting object, and yet it has made us rewrite pages, rethink laws, reopen questions we thought were settled. Its spectrum, its light, its rhythm, all of it tugged at the boundaries of what we thought a comet was. And that's what science is meant to do, isn't it? To be unsettled, to be curious enough to admit confusion. Because in truth, the cosmos doesn't fit inside the diagrams we draw. Every rule we write down is temporary, provisional, a fragile scaffolding built to hold our ignorance in place while we reach for something higher. And, well, sometimes it takes a traveler from the stars to remind us of that. You see, when we talk about rewriting textbooks, we imagine something grand, a revolution, a breakthrough, but it's never loud. It happens in the smallest shifts of understanding. A line added to a model, a graph adjusted by 0.5%, a single word changed from certainty to probability, from is to might be. That's where the real revolutions live, in the commas of thought. And perhaps that's what Three-Eye Atlas gives us. Humility, not the kind that diminishes, but the kind that opens space for wonder. It tells us that even in the age of high-resolution telescopes and quantum detectors, the universe can still surprise us. That the unknown isn't shrinking, it's expanding faster than light, faster than comprehension. When the data first came in, the symmetrical jets, the featureless spectrum, the light curve that rose and fell like breathing, it must have been tempting to force it into a familiar mold, to call it a comet or an asteroid or a fragment. But the truth resisted. The data whispered something else. Not wrong, not broken, just incomplete. And that's the thing, data is never wrong. It's just not yet enough. Each telescope, each instrument captures one frame of a moving picture. And perhaps the greatest challenge in 2025 isn't collecting more data, but learning how to see across time, how to assemble moments into motion, to read variability, not as error, but as life. So maybe this is the real gift of snapshot science. It forces us to remember that the universe doesn't stand still while we measure it, that every observation is an act of participation. We're part of the scene we're studying. Our instruments hum under the same solar wind. Our atoms tremble in the same field. And that awareness, I think, is deeply humanizing. It pulls us out of the illusion of detachment. It reminds us that objectivity isn't coldness, it's compassion for complexity. I suppose, well, that's why I find the story of Atlas so haunting. It's a small body, yes, but it has become a kind of philosophical test. It asks whether we're willing to let go of the need for closure, whether we can hold an unanswered question and still call that knowledge. Because science, at its best, is not about final answers. It's about good questions, the kind that last, the kind that echo across generations. And the question that Atlas leaves us with is one of those: what else can the universe make? What combinations of matter and field and light have we not yet seen, simply because we never thought to look? Maybe there are materials that shimmer between solid and plasma. Maybe there are bodies that self-organize under magnetism, not gravity. Maybe there are entire classes of objects, comet-like, yet utterly new, drifting between systems, carrying the fingerprints of environments we can only imagine. The thought is staggering, but it's also liberating, because it means we haven't reached the edge of discovery. We've barely left the shore. And that's the spirit, I think, we must keep alive. The willingness to be astonished, the courage to be wrong, the grace to let evidence lead, even when it takes us places we didn't plan to go. When future astronomers look back at this era, they might not remember the numbers, the magnitudes, the orbital fits, the equations. What they'll remember is that we looked up, saw something inexplicable, and chose wonder over dismissal. That we refused to shrink the universe to fit our comfort. And maybe that's the quiet beauty of it all, that science at its most rigorous is also the most romantic thing we do. It's the act of falling in love with truth again and again, knowing it will never fully belong to us. 3i, Atlas, Oumuamua, Borisov, they are all part of this long conversation between humanity and the cosmos. Each visitor a new voice, each trajectory a new verse. They come, they shimmer, they fade, and yet their echoes linger in our models, in our theories, in the way we think about what's possible. So when we talk about rewriting textbooks, maybe what we're really rewriting is our own perception of certainty. Maybe what's changing isn't the knowledge, but the knower. It's not just about comets or plasma or dust. It's about how we learn slowly, imperfectly, beautifully to coexist with mystery. And perhaps that's why the universe keeps sending us these messengers, to remind us that the frontier of science is not a line, but a horizon one that recedes as we approach. To remind us that progress isn't about control, but communion. Each interstellar visitor, in that sense, is a free sample from the cosmos, a piece of another world delivered to our doorstep, asking nothing but curiosity in return. We can study it, yes, but we can also listen to it not as a problem to be solved, but as a poem written in motion. And that might be the deepest lesson of all. That science and wonder are not opposites, they are siblings. They grow together, they depend on each other. Wonder asks the question, science teaches us how to listen for the answer. As the years go on, our instruments will sharpen, our reach will lengthen, and new objects will cross our skies. Some will fit the models, most will not. But if we carry this humility with us, this patient, luminous curiosity, then each new discovery will be more than data. It will be dialogue. And I suppose, well, that's where the story must go next. Because if these interstellar messengers have shown us anything, it's that we've only just begun to understand the languages the universe speaks in dust, light, magnetism, time. And somewhere out there, another visitor is already on its way. Another flicker, another shape, another chance to ask again who we are in this vast conversation. And when it arrives, whether next year or 1,000 years from now, I hope we'll still be ready to listen. Not just with instruments, but with awe. Not just with data, but with reverence. Because in the end, that's what keeps us looking up. Not the certainty of answers, but the promise of wonder yet to come.